This tutorial looks at conventional symbolism, which is a way of writing the name of an element or its symbol along with its mass number, and also isotopes and the effect that isotopes have on a number on the periodic table called the relative atomic mass. We start by recalling how the periodic table can give us some information about the subatomic particles in an atom of an element. And when we look at the periodic table, we can see that there are two numbers associated with each element. So when we look at, for example, aluminium here, we can see that the number at the bottom, in this case it's 13, is on the key the atomic number or proton number. That gives us the number of protons. It also, of course, gives us the number of electrons, because for a neutral atom the number of protons and electrons are the same. But there's also another number here which is 27, which is called the relative atomic mass. Now in most cases this is the same as the mass number, but it isn't always the case, because as you can see the mass number would have to be a whole number, and in a couple of cases, chlorine particularly here and copper here, the relative atomic mass isn't a whole number, so it can't describe the number of protons added to the number of neutrons. There must be something more to it than this. And that's because there's something called isotopes that we need to learn. Isotopes being varieties of the same element which have got the same atomic number and therefore have the same number of protons, but have got different mass numbers, therefore different number of neutrons. So isotopes are varieties of an element that have the same atomic number but different mass numbers. Now if they have the same atomic number, they've got the same number of protons. But if they've got different mass numbers, and the mass number is the number of protons plus neutrons, then the number of neutrons must be different. When we looked on the periodic table, we saw that chlorine had a mass number of 35.5, and that's because it's got some atoms that have 35 as their mass and some that have 37 as their mass. That's because some of them have got 35 minus 17, 18 neutrons, and some of them have got 37 minus 17, 20 neutrons. It's the relative atomic mass that's the average mass of its atoms, and that's the one which is shown in the periodic table, not the mass number of an individual isotope. Now we know that for every 4 chlorine atoms, 3 of them weigh 35 and 1 of them weighs 37. So if we were to take the average mass of 4 atoms, the mass of the 3 which weigh 35 would be 3 times 35, which is 105, and the mass of the one which weighs 37 would be 37. Add them together and the total mass of those 4 atoms weigh 142. Now if 4 atoms weigh 142, then the mean or average mass of an atom is a quarter of 142, which is 35.5, and this is what's known as the relative atomic mass for chlorine. Now in most cases, elements have either one isotope only, or have so much more of one isotope than any other that when we work out the relative atomic mass, it comes out to very, very close to a whole number and is therefore rounded in our periodic table. It's only in a couple of cases that it doesn't round nicely and we have this decimal point shown. Conventional symbolism allows us to identify a particular isotope of an element by its symbol but also its mass number, which would change from isotope to isotope. So it's the symbol and the mass number written in either of two ways. Here we have an atom of sodium with 11 protons, 12 neutrons and 11 electrons. That means that when you look at its mass number, it's got 11 protons and 12 neutrons. It has a mass of 23. So we can say that it's sodium-23, or we can write that 23, its individual mass number, in front of and above the symbol for the element, 23Na. Now the conventional symbolism of each of these ones, calcium, we'd be talking about an isotope that weighed 40, so calcium would be calcium 40 or 40Ca. Iron, 56, would be iron-56 or 56 up in the air Fe. Bromine might have a couple of isotopes, but let's go for the one that weighs 79. So we'd write bromine -79 or 79Br, and lead 207, so we'd write lead-207 or 207 Pb. And just to remind you how you can use data from a table in order to work out the number of protons, neutrons and electrons for a particular element, let's take these three examples. Aluminium, it's got an atomic number of 13, which means it's got 13 protons. As it's a neutral atom, it's also got 13 electrons. Now the mass number is the protons plus neutrons, so if it's got 13 protons and then the protons and neutrons add up to 27, that must mean it's got 14 neutrons. Potassium, atomic number 19, so the number of protons and the number of electrons are each 19, but 19 plus the number of neutrons adds up to 39, so that must be 20 neutrons. And chlorine, this particular isotope of chlorine has got an atomic number of 17 and a mass number of 37, so proton number and electron number is both 17, but for this isotope in particular, the number of neutrons would be 37 take away 17, which is 20. Here's some questions, and it might be useful to have a periodic table in front of you to help you answer these. How many protons in an atom of carbon-12? Well, it's certainly not 12, because 12 is the mass number, and the mass number is the number of protons plus neutrons. So to find out the number of protons, we need to refer to a periodic table to find carbon on the periodic table, and it has an atomic number of 6, which means it has a number of protons of 6. How many electrons in an atom of calcium-40? Again, it's not 40, because 40 is the number of protons plus neutrons. It's the mass number. To find out the number of electrons, we need to look up calcium on a periodic table. It has an atomic number of 20. That means it's got 20 protons. And as it's a neutral atom, it will also have 20 electrons. How many neutrons in an atom of 2914 silicon? Well, here we are given information in the question. The top number here is the mass number. The bottom number here is the atomic number. So if the top number here is the number of protons plus neutrons, and the bottom number here is the number of protons, then the difference between them is going to give us the number of neutrons, which is going to be 29 minus 14, or 15. Therefore, the answer here is 15 neutrons.